Hello everyone. Today we will going to see some practice questions from the chapter Structure of Atom. Okay, so this is NCERT chapter 2 and today we will going to see some practice questions of JEE PYQs which have been covered or which have been there in the previous examinations of JEE. So let's start with the topic NCERT chapter 2 Structure of Atom JEE PYQs part 4. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. So let's begin with our first question, and this is a JEE PYQ, and this is covering the NCERT section 2.5.1 in our NCERT textbook in the Structure of Atom chapter. The question says that according to the wave particle duality of matter by the de Broglie, which of the following graph plot represents most appropriate relationship between the wavelength of electron, that is lambda, and momentum of electron? So you have to tell from the given options the one plot which is correct according to the wave particle duality of matter, which is given by de Broglie, and which is telling the most appropriate relation between the wavelength of electron, that is lambda, and the momentum of electron, that is p. So this question has been in the 2024 examination of JEE. The four options provided are the A graph, where the graph is between the wavelength of the electron versus the momentum of electron, and it is a straight line starting from the very zero. In the B graph, we have the graph, or you can say curve graph, between the wavelength of electron lambda versus 1 by momentum of electron. In the third graph, we have the graph between the momentum of electron versus the wavelength of electron, and it is a straight line starting from the x equals to 0. And in the D graph, we have again a curve which is representing a graph between the wavelength of electron versus the momentum of electron. So you have to tell which graph is correctly representing the relationship between the wavelength of electron and the momentum of electron as per the wave particle duality of matter given by the de Broglie. So you got some time to think about it and try to conclude it. Then we will see at which option is our correct answer. Okay, let's see. So for this given question, the correct answer is option D, the option D graph. So according to the de Broglie's hypothesis, the wavelength represented by lambda of a particle is related to its momentum represented by small p by the equation lambda is equals to h by p. H is a constant, p is a momentum, and lambda is wavelength of the particle. This is also a NCERT equation marked as 2.22 in the chapter Structure of Atom. So h is a constant which is Planck's constant. It has a specific value in the joule second. Okay, so this is the lambda value given by the Broglie or de Broglie's hypothesis. So this implies that p, that is the momentum, is equals to h by lambda. We just cross our term from the left hand side to right hand side, and this lambda will go in the denominator and the momentum will go here at the place of the lambda. So momentum is defined as h by lambda. That means momentum and the wavelength are inversely related. So momentum increases, the wavelength decreases, and vice versa. So graphical representation, that how can you graphically represent, or on the basis of that p and lambda, that is the momentum and the wavelength, are inversely related, then how can you graphically represent them? So inverse relationship, that means the graph that represents this relationship would be a hyperbolic curve, so the graph will show the inverse relationship between the variables which we are taking on the y-axis and the x-axis. So the graph that represents this relationship, that is inverse relationship between the p and lambda, would be hyperbolic curve, where the x-axis represents the momentum, that is p, and the y-axis represents the wavelength, that is lambda. As the p increases, momentum increases, the lambda will decrease as per the inverse relationship between them. So this will be the correct graph, that as per the lambda is increasing, the value of lambda increasing, the value of momentum will decrease, right? Because as you are going in the increasing value of lambda, the p is increasing, going in this reverse direction in the left hand side, right? So this graph is representing the correct relationship, or the correct plot representation of wavelength of electron lambda and the momentum of electron p. Hence the correct answer is our option D. Okay, now let's move to our next question. This is a JEE PYQ, and this question is covering the NCERT section 2.6.1 in the chapter Structure of Atom. The question is saying that the number of electrons present in all the completely filled subshells having n equals to 4 and s equals to half is, where the principal quantum number and the spin quantum number. So basically what you have to do, you have to tell that what is the number of electrons which are present in all the completely filled subshells having n equals to 4 and s equals to half. The electrons which are present in the completely filled subshells which is having n equals to 4 and s equals to half. Now if I try to explain you, s is particularly the spin quantum number, and n is representing the principal quantum number, and also the s is specific for a particular electron, because if you remember, in a particular subshell there is a representation of electrons in two terms, like up higher spin or lower spin, right? And both the spins have different values. Higher spin will be positive half, lower spin will be having the negative half, right? So in a subshell, every electron is having their specific spin quantum number. So if we have given this s value, then we are talking about a specific kind of electrons. Okay, so the question is asking that you have to tell the number of electrons which is present in all the completely filled subshells which is having n equals to 4 and s equals to plus half is. So you have to count the electrons and then you can tell the answer. You got some time, try to solve it, then we will see that which answer will be the. Okay, so you got some time, try to solve it, and then we will see that what is the correct answer. Let's see. So for this question, the correct answer is 16. So how it is 16? So first of all, let's find out the number of orbitals for our principal quantum number equals to 4, n equals to 4. So if we have n equals to 4, the number of orbitals for a given principal quantum number n is given by n square. If n is given, which is given here as 4, the number of orbital will be n square, that means 4 whole square, that means 4 times 4 will be 16. So n square is 4 square is 16. Hence that there are 16 number of orbitals which are present for n is equals to 4. Okay, now we have to find out the number of electrons. So the electrons with s equals to plus half in these orbitals. So each orbital can hold 2 electron, you know that, right? So basically we have shell, every shell have some number of electrons in it, and the orbitals can hold 2 electrons. Okay, each orbital can hold 2 electrons. Each subshell is also can have a particular amount of electron and a particular amount of orbital, and each orbital can hold 2 number of electrons in one with s equals to plus half and one with s equals to minus half. That means upper spin and the lower spin. If we are only considering the electrons which is having the s equals to plus half, then each orbital will have one such electron, right? So if we are considering that s equals to plus half, that means only the higher spin one, then we can say that if an orbital can contain the 2 electron with 2 s values, plus half and minus half, and we have tell that you have to only consider the plus half value electrons, that means we have to take one electron from each orbital, right? So we are considering the electrons with s equals to plus half, that means each orbital will have one such electrons in it. So the number of electrons with s equals to plus half in all the orbitals for n equals to 4 is 16. Okay, so that the number is counting as 16. Okay, so if I will explain that how that will be 16, because we just discovered that the orbital will be 16 for n equals to 4, because if the n is given, the principal quantum number is given, the number of orbitals corresponding to the principal quantum number will be n square. Now 4 square will be 16. That means the total number of orbitals will be 16. Now each orbital can contain 2 electron. That means if you have to find out the number of electrons in n equals to 4 orbital subshells, then you can say that will be 16 times 2, because each orbital contains 2 electrons, right? There are 16 orbitals, so one orbital contain 2 electron. That means total number of electrons in the 16 orbital will be 16 times 2. But here we are only talking about the s equals to plus half. Each orbital contain 2 electrons with plus half and minus half, but we have to consider only plus half one. That means each orbital should have one such electron having the plus half value. That means we are saying that the number of electron will be 16, right? Equals to the number of orbitals. Hence the correct answer is 16. Okay, moving on to our next question. Now this is a JEE PYQ, and this is covering the NCERT section 2.6.5. The question is saying that the correct set of 4 quantum numbers for the valence electron of rubidium atom is, the rubidium atom atomic number is 37. Z, we use the representation for the rubidium atom. You have to tell the correct set of 4 quantum. So each electron is associated with 4 quantum numbers. That means 4 quantum numbers is possible for an electron. So you have to tell the correct set or correct value of the 4 quantum numbers for valence electron of rubidium element, whose atomic number is given as 37. The 4 options given are 5, 0, 0 plus half, 5, 0, 1 plus half, 5, 1, 0 plus half, or 5, 1, 1 plus half. You have given some time, try to solve it, and then we will see that which option will be the correct answer. Okay, let's see. So for this given question, The correct answer is option A. That is, the 4 quantum number values are 5, 0, 0 plus half. Rubidium has 37 electrons because the atomic number related to that is 37. That means 37 electrons are present in the rubidium. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. If you see in the last orbital, we have 5s1. That means 1 electron. So principal quantum number for the valence electron or for the last electron is n equals to 5. Azimuthal quantum number, that is L, for the s orbital, because azimuthal quantum number is associated with the particular orbital. We have the last valence electron in s orbital, so L value will be 0. The magnetic quantum number, which is represented by m subscript L, for L equals to 0 is 0, because if you remember, the magnetic quantum number value is depending upon the value of the azimuthal quantum number from minus L to plus L. But if the L value is 0, then for L equals to 0, ML will be 0, because plus 0 minus 0 doesn't make sense. Now spin quantum number, the fourth quantum number, represented by S, and for this 5s1 we have either plus half or minus half, which is usually the first electron in an orbital is taken as plus half, so we are considering the plus half here, the fourth quantum number value. Okay, so these are the 4 quantum number values and the respective quantum numbers associated with the valence electron of rubidium, which is 5s1. So the correct answer is option A, representing the 4 quantum numbers 5, 0, 0 and plus half. Option A is the correct answer. Okay, moving on to our next question. This is a JEE PYQ, and this question is covering the NCERT section 2.3.3 in the chapter Structure of Atom. The question is having a table in which 2 columns are present and 4 rows are present. The 2 column represents the 2 lists. The first list is for spectral series of hydrogen, and the second list is for the spectral region or higher energy state. Now the 4 columns indicating A, B, C and D having the list 1 value as Lyman, Balmer, Passion and Funt. Similarly, in the list 2 we have 4 rows, first, second, third and fourth. The first row in the list 2 is infrared region, second row is ultraviolet region, third is infrared region, and the fourth one is visible region. So basically we have given the spectral series for hydrogen in the list 1 and their higher energy state or spectral region with respect to the spectral series of hydrogen in the list 2. You have to correctly match these, that which spectral series corresponds to which spectral region. The 4 options given are A is corresponding to second, B to third, C to first and D to fourth. A is corresponding to first, B to third, C to second and D to fourth. Or A is corresponding to second, B to fourth, C to third and D to first. Or A is corresponding to first, B to second, C to third and D to fourth. So these are the 4 choices you have. Try to match the list 1 with the list 2 correctly and then you can tell the correct answer. So you got some time for that. Try to solve it. We will see that which option will be the answer for this question. Okay, let's see. So for the given question, the correct answer is option C. A is matching with the second, B with the fourth, C with third and D with first. So A, that is Lyman spectral series, is corresponding to the second, that is the ultraviolet spectral region, That means Lyman is or Lyman series is corresponding to the ultraviolet region of the spectra. Balmer series, that is the B, is corresponding to the fourth, that is visible region. C, which is Paschen, is corresponding to the infrared region, which is third. And D, that is Fund, is corresponding to the infrared region. So these are the correct matchings. Lyman is for the ultraviolet region, Balmer for the visible region, Paschen is for the infrared region, and Fund is also for the infrared region. So our correct answer is option C, that is A to second, B to fourth, C to third, and D to first. Okay, let's move on to our next question. This is a JEE PYQ covering the NCERT section 2.6.3. The question is saying that given below are two statements. The statement 1 is the orbitals having the same energy are called as degenerate orbitals. Statement 2 is in the hydrogen atom, 3p and 3d orbitals are not degenerate orbitals. In the light of the above statements, statement 1 and statement 2, choose the most appropriate answer from the options given. The options are statement 1 is true, but statement 2 is false. Both the statement 1 and the statement 2 are true. Both the statement 1 and statement 2 are false. Statement 1 is false, but statement 2 is true. So you have to select that which option is correctly choosing or correctly matching the question and which is the correct answer. So you got some time, try to solve it, and then we will see that which option is the correct answer. Okay, let's see. So for this given question, the correct answer is option A. Statement 1 is true, but statement 2 is false. Statement 1 is the orbitals having the same energy are called as degenerate orbitals. Okay, this is a true statement. This is correct. The orbitals which is having the same energy, how you tell that what is the energy of the orbitals? You can choose that by n plus L value. Okay, n is representing the principal quantum number, L is azimuthal quantum number. So the orbitals having the same energy are called degenerate orbitals. Statement 2 on the other hand is that in hydrogen atom 3p and 3d orbitals are not degenerate orbitals. Now this is incorrect. This statement is incorrect. So in a hydrogen atom, all the orbitals with the same principal quantum number, that is n, are degenerate. Now regardless of their L value, so 3p and 3d are degenerate in the hydrogen. Okay, so in a hydrogen atom, all the orbitals with the same principal quantum number, that is n, if the n is same, like in the case of 3p and 3d, then all the orbitals are degenerate if n is same for those two, regardless of the L value, whatever the L value be, because L value depend on p and d orbitals, right? That is which orbital we are talking about, L depends on that. But in a hydrogen atom case, all orbitals with same principal quantum number are degenerate regardless of their L value. That's why 3p and 3d are degenerate in the hydrogen. So that's why the correct the statement 2 is not the correct one. Meanwhile, the statement 1 is the correct one. Hence, the correct answer is option A. Moving on to our next question. Now again, this is a JEE PYQ, and This is covering the NCERT section 2.3.3. Now the question is saying that number of spectral lines obtained in the helium positive spectra when an electron makes transition from fifth excited state to first excited state will be. So you have to tell that how much the number of spectral lines you will going to obtain in the helium positive spectra, not in the hydrogen, but you are talking about helium positive spectra, when the electron makes a transition from fifth excited state to the first excited state. N2 is equals to, okay, N1 equals to 5, N2 equals to first. Okay, so when this transition happens, then how much is the count of number of spectral lines which is going to obtain in the helium positive spectra? You have to tell that. So you got some time, try to solve it, figure out the number, and then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is 10. So the number of spectral lines you can calculate by this specific formula, which is given by delta n multiplied by delta n plus 1 divided by 2. Now delta n is representing the initial minus the final excited state. Okay, that is Ni minus Nf. You have given the both. So we have given that initial is sixth. Okay, initial is the fifth excited state. So fifth excited state, that is Ni equals to 6, because okay, now you have to understand this, that Ni equals to 6, and but it is, we are calling it as fifth excited state. So n equals to 0 is the ground state, n equals to 1 is the first excited state. Okay, n equals to 1 is the ground state, n equals to 2 is the first excited state, n equals to 3 is the second excited state. Similarly, n equals to 6 is the fifth excited state, and n equals to 2 is the first excited state. That's why we are saying that initial n is 6th and nf value is 2. Okay, so we put this in the delta n formula, and then the delta n value we can put in the number of spectral lines formula to get the number of spectral lines we will going to obtain in the helium positive spectra. So delta n will be 6 minus 2, that is 4, and the number of spectral lines will be 4 multiplied by 4 plus 1 by 2. 4 plus 1 is 5, so 4 times 5 by 2, 20 by 2, which is 10. So the number of spectral lines you will obtain in the helium positive spectra when the electron make transition from fifth excited state to the first excited state is 10. Hence the correct answer is 10. Okay, moving on to our next question. This is a JEE PYQ. This is covering the NCERT section 2.3.3 in the chapter Structure of Atom. Question is saying that if the electromagnetic radiation of the wavelength 242 nanometer is just sufficient to ionize the sodium atom, the ionization energy of sodium in the kilojoule per mole is. If we have given the electromagnetic radiation whose wavelength is 242 nanometer, and we are also claiming that this electromagnetic radiation of this particular wavelength is sufficient, just sufficient to ionize the sodium atom, then the ionization energy of sodium you have to calculate in the kilojoule per mole units. You got some time, try to solve this, and then we will see that what is the correct ionization energy of the sodium. Okay, let's see. So for this given question, the correct answer is 494.65 kilojoule per mole. So let's calculate this stepwise. The step 1 is write down the given data, whatever we have given. So first of all, we have to consider that the wavelength is given as 242 nanometer, which is 242 into 10 to the power minus 9 in the meters. The Avogadro's number which we're going to use, which is Na, which is equals to 6.022 times 10 to the power 23 mole inverse. The Planck's constant we will going to use, H is representation of Planck's constant, which is equals to 6.626 times 10 to the power minus 34 joule second, and the speed of light, C, is equals to 3 times 10 to the power 8 meter per second. So these are the given data which you are going to use in the solution. Now the step two include the calculation of the energy of one photon. So E, that is energy, is given by hc by lambda. H is the Planck's constant, c is the speed of light, and lambda is the wavelength of the electron. E is the energy, so we have to plug in the values, the given values. So E will become the H value, which is 6.626 times 10 to the power minus 34, multiplied by the C, which is 3 times 10 to the power 8, divided by the lambda, which is 242 nanometer. That means 242 times 10 to the power minus 9 in the meters. So this is the energy in the joules. So the energy of one photon is, we calculate this and the fraction come out as E equals to 8.21 times 10 to the power minus 19 joule. Now this is the energy of one photon. You have to tell the ionization energy of sodium. So the step 3 includes the calculation of ionization energy per mole by multiplying by Avogadro's number, Na. So ionization energy per mole is given by the energy of one photon multiplied by the total number of atoms present, that is Avogadro number, 6.022 times 10 to the power 23. So total number of atoms present in 1 mole. So this is equals to the ionization energy per mole. Now when you solve this product, it will give us the value. The ionization energy per mole is going to be 494650 joule per mole. Now you have to tell your answer in the kilojoule per mole, so you just have to convert it in the kilojoule per mole. So when you convert it to the joules term in the kilojoules term, then ionization energy in the kilojoule per mole will become the quantity in the joules divided by 1000. This will be 494.65 kilojoule per mole, and this is good. This is going to be our correct answer for the given question. Okay, let's move on to our next question. Now this question is a JEE PYQ and this is covering the NCERT section 2.6.5. Question is saying that the 4 quantum numbers for the electron in outermost orbital of potassium are, the atomic number of potassium is given as 19. You have to tell the quantum number or the 4 quantum number for the electron present in the potassium in the outermost orbital. The options provided are n equals to 4, L is 2, M is minus 1, and S is plus half. N equals to 4, L is 0, M is 0, S is plus half. N equals to 3, L is 0, M is 1, and S is plus half. Or N equals to 2, L is 0, M is 0, and S is equals to plus half. These are the 4 options given, including the 4 quantum number values, including the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. You got some time, try to solve this, and then we will see which option corresponding to the correct answer. Okay, let's see. So for the given question, the correct answer is option C, that n equals to 3, L equals to 0, M equals to 1, and S equals to plus half. Again, let's calculate this stepwise. So first of all, you have to know the electronic configuration of potassium. So Z is equals to 19. It is already given. So electronic configuration will be, the potassium is having 19 electrons. So electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now the outermost orbital is s orbital, having the 1 electron in it, and the subshell is 4th, so 4s1. Now the step 2 involves the quantum number for the 4s1 electron. So different quantum numbers for the electron in the 4s1 is principal quantum number, which is 4, because the 4 is written here, right? So n is equals to 4, since it's the 4s orbital. Azimuthal quantum number represented by L. For s orbital is 0, so L will be 0 for s orbital. Magnetic quantum number represented by Ml is also 0 for L equals to 0. So for L equals to 0, only Ml 0. Otherwise, the Ml corresponding to the minus L2 plus L values. Spin quantum number will be having the value of plus half, which is commonly taken as plus half for a single electron in an orbital. And hence, our correct quantum numbers are the 4, 0, 0 and plus half, as present in our C option. So our next question, which is a JEE PYQ, and it is covering the NCERT section 2.6.1. So the question is, the maximum number of orbitals which can be identified with n equals to 4 and ml equals to 0 is. We have given the value of two quantum numbers, n and ml. You have to tell the maximum number of orbitals which can be identified with these two quantum numbers. You have some time, try to solve this, and then we will see that which is the correct answer. Okay, let's see. So for this given question, the correct answer is 4. So the possible values of azimuthal quantum number for n equals to 4, that is included are step 1. So for n equals to 4, the possible values of L is 0, 1, 2 and 3. Because in the n equals to 4, we can have s orbital, we can have p orbital, d orbital and f orbitals. So for s, L is 0, for p, L is 1, for d, L is 2, for f, L is 3. Now for each L value, ml ranges from minus L to plus L, including the 0. So for L equals to 0, ml is 0, that means only one orbital will exist. For L equals to 1, ml is minus 1 to plus 1, that means minus 1, 0 and plus 1. That means ml is 0, not possible. Ml equals to 0 possible, and there is one orbital. For L equals to 2, ml will be minus 2 to plus 2. So minus 2, minus 1, 0, plus 1, plus 2. ml equals to 0 is possible, so that means one orbital. Now for L equals to 3, the ml is minus 3 to plus 3. That means minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. ml equals to 0 is possible, that means one orbital. So we have to tell that n equals to 4 and ml should be 0, the number of orbitals. ml 0 is present in L equals to 0, L equals to 1, L equals to 2, L equals to 3, in all the 4, right? That's why we are saying that the maximum number of orbitals with these two quantum number is 4. Now The step 2 includes the sum of the possible orbitals simply. So there is one orbital for each value of L, as I said, right? So E for each value of L, we are having ML equals to 0. So total number of orbital will be 1 from each value of L. So L for S 1, L for P 1, L for D 1, L for F 1. Each is having one orbital corresponding to ML equals to 0. That means total number of orbitals which can be identified with n equals to 4 and ML is equals to 0 is 4. Hence our correct answer is 4. Okay. Okay, so this is a JEE PYQ and it is covering the NCERT section 2.3.3. Question is saying that the value of Rydberg constant represented by RH is 2.18 times 10 to the power minus 18 joule. The velocity of electron, which is having the mass of 9.1 times 10 to the power minus 31 kg in the Bohr's first orbit of hydrogen atom, is this something dash multiplied by 10 to the power 5, which is nearest integer you have to tell. So you have to tell the velocity of electron in the nearest integer possible. You have given some time, try to solve this and then we will see that what is the correct answer. Okay, let's see. So for this given question, the correct answer is 22 times 10 to the power 5 meter per second. That means nearest integer is 22. So the V, that is velocity, is 2.188 times 10 to the power 6 times Z by N. This is the term, right? So velocity is 2.188, that is the Rydberg constant RH multiplied by Z, which is atomic number, divided by N. So so hydrogen atom in the first Bohr orbit having Z is 1 and N is also 1 because it is in the first orbital. So N is 1, Z is also 1 for hydrogen. So V is given by 2.188 times 10 to the power 6 multiply by 1 by 1, that is 1. So this is corresponding to 22 as the nearest number multiplied by 10 to the power 5. Hence the correct answer is this, 22 times 10 to the power 5. Okay, that's all. Thank you so much.